This video is going to look at two special cases of solving a system of equations. And the first system we have here is 3x plus 2y equals 3 and 6x plus 4y equals 14. And I'm going to set this up solving using elimination. And that means I want to add the two equations together to cancel out either the x or the y variable. So we have 3x and 6x, that would give us 9x, 2y and 4y would add together and give us 6y. So we want to figure out, is there something we can multiply one of the equations by so that we can cancel out either the x or the y? Well, 3x and 6x, we can see here that if we were to multiply the 3 by 2, that would give us a 6x, but 6x and 6x would be 12x, so we want to multiply the 3 by a negative 2. So if we multiply the first equation by a negative 2, we would get a negative 6x, and of course then a negative 6x and a positive 6x would cancel out. So here we're going to get negative 2 and 3 is negative 6x, negative 2 and 2y would be a negative 4y, and then of course negative 2 and 3 would be a negative 6. And we'll bring down the other equation, which is 6x plus 4y equals 14. So now when we add together, the 6x and the negative 6x are going to cancel out. And you'll notice here also we have a negative 4y and a positive 4y. The variable y is also going to cancel, so we're left with 0 equals a negative 6 plus 14, which is equal to 8. Now, does 0 equal 8? This here is a false statement. So what that tells us, there is no solution to this system of equations. So it's simply no solution. So what that means is there's no x and y value, there's no ordered pair that would make this satisfy both equations at the same time. Now, what that means, if we were to look at graphing these equations, that means that they would never intersect. They would be parallel. So let's take a look at the first equation. If we solve that for y, we would have 2y is equal to a negative 3x plus 3. Okay, so we move the 3x to the other side. And then we would divide by 2, so y would be equal to a negative 3/2 x plus 3/2. And then if we solve the other equation, let's see, we would have the 4y. We want to get rid of the 6x, so that would be a negative 6x plus 14. And the divide by 4, we get y equals a negative 6x over 4 plus 14 over 4. And here we could simplify negative 6 over 4. We could divide by 2 and we'd have a negative 3/2 x plus 2 into 14 is 7 and 2 into 4 is 2. So now if we were to graph each one of these equations, for example, the first one we have is a negative 3/2 x plus 3/2. So we go to y equals and we type in a negative 3/2 x plus 3/2. And then if we go to the other equation, we have a negative 3/2 x plus 7/2. Negative 3/2 x plus 7/2. Okay, and if you'll notice here, there's kind of a clue that we're going to have lines that don't intersect. And notice here, they are going to be parallel. So therefore, they do not share a common point. So therefore, there is no solution. Okay, and what that really tells us is they don't have a common point that's going to satisfy both of the equations at the same time. And if we were to look closely here, if we notice here we have a slope of a negative 3/2 and here we have a slope of a negative 3/2. Well, that tells us that if each line has the same slope, then they're increasing or decreasing at the same rate, so therefore they're never going to cross each other, so therefore no solution. All right, the other possible case is in the system we have here. Well, we have a negative 3/4 x plus 1/4 y equals 5/4, and the other equation is negative 3x plus y equals 5. And here, if we try to solve this using elimination, you may find that the first thing is easiest to do is to get rid of the fractions. So we know this first equation has a denominator of 4, so I would recommend multiplying this first equation by 4, and that way we're going to cancel out uh, the denominator. So if we do that, we would end up with here, the 4's cancel, and we'd have a negative 3x plus 1y equals 5. And if I bring down the second equation, which is a negative 3x plus y equals 5. Now at this point, you probably notice they're exactly the same equation. Now if you don't notice this and you try to go on and continue to solve using elimination, then all we would have to do is, for example, we could multiply this first equation by a negative 1, and that would give us 3x minus y equals negative 5. And then you're going to notice then on the bottom we have 3x, or I'm sorry, negative 3x plus y equals 5. So then if we go to add the equations together, here 3x and negative 3x cancels, negative y positive y cancels, so we're left with 0 equals, and once again here the 5's even cancel, so we have 0 equals 0. Now this here is a true statement. So if your variables both cancel out and you have a true statement such as 0 equals 0, 4 equals 4, negative 2 equals negative 2, if you have two numbers that are equal and you have a true statement, then what that tells us is we're going to have actually many solutions to this equation. Okay, so there's going to be infinite many solutions. Now to represent those solutions, we're actually going to, for example here, one way to do this, we can kind of represent this, and we're going to say up here where we canceled out, we're going to let your y variable equal a. Okay. Now, for example, let's just pretend that if we were using elimination here, normally with elimination in the previous video, when we got y equals a number, we would take that number and then substitute it into the other equation. Well, in this case, both equations are the same, and I'm using the letter a because that's what it seems like most textbooks will use. You could use any variable that you want here. I'm just using a. So if we let y equal a, and we're going to substitute then a in for y, and solve for x. So that means here we would have a negative 3x. So in place of y, we're going to substitute in our number, in this case, the a, equals 5. And then if we solve for x, we would have a negative 3x is equal to, subtract the a, so that's a negative a, and we still have the plus 5. And then we're going to divide by the negative 3. So here we would, if we divide by a negative 3, we're going to end up with x equals, two negatives make it a positive, so that would be positive 1/3 a minus 5/3. So what we have here is a representation of our answer. For example, we're saying x is 1/3 a minus 5/3. So if we write that as an ordered pair, we would have 1/3 a minus 5/3, comma, and our y value, we said we're letting that simply be a. So that would give us kind of our ordered pair where 1/3 a minus 5/3 is representing our variable x, and the a is representing our variable y. So this just gives us a form of the answer. Now, really, what do we have here? We have this system is essentially one line. So if we were to graph negative 3x plus y equals 1/5, then we could solve this for y, and that'd be 3x plus 5. So if we were to graph this, now I'm only going to graph one of these because they're the same equation. So y equals 3x plus 5. Let's see, is that what we had? Y equals 3x plus 5. We'll go to zoom standard. And there's the line. And if we were to graph the other one, it would be right on top of this because we have exactly the same line. So what's going to satisfy this equation is any point that falls on this line, because any point that falls on this line is also going to fall on the other equation because it's exactly the same line. So what we're doing here by using, let's go ahead and copy this over. By using this 1/3 a minus 5/3 comma a, what we're saying is that's going to give us any point that falls on this line. Okay, so for example, if we said that, and I'm just going to randomly pick a number here, if we said that your y was 0, then if y is 0, then that means the a is 0. Okay, so then we would plug 0 in for a, so 1/3 times 0 is 0, so then your x value would be a negative 5/3. So basically that gives us the point negative 5/3, 0 is a point on this line. So if I went back to the calculator and we went to second function trace, and number 1 is value, and if I type in a negative 5/3, we want to know what does y equal when x is a negative 5/3, and hopefully if we did this correctly, we know it should be 0. And sure enough, we get negative 5/3, which is a negative 1.6 repeating, and notice here our y value is 0. So this answer that we come up with here is just simply a format of all of the infinite many solutions that we would have. So here we have two examples where one is the equation, the system of equations, there is no solution because the lines never intersect, and the other possibility is that you have many solutions because you have exactly the same line.